So this is lesson 4.5, and we're going to talk about angle side angle and angle side. So two other ways that we can prove triangles congruent. Yay, more ways. Because the more we have, the easier it is then. So this warm-up, you can go ahead and try that on your own, and if you want to check answers, you can check with me in class for those answers. Good review there. Make sure I would start with point slope on this one. So remember y minus y1 equals m parenthesis x minus x1, and then plug it in, and then you can get it into slope intercept form after that. Okay, so try that, review. And in this lesson, we're going to apply angle side angle and angle side, and then we're going to get to hypotenuse leg in the next lesson. We're going to kind of split this into two days, and then we'll construct some problems using that. So our first definition is the included side. So just like an included angle, the side between two angles. So it has to be between. So here it is between those two angles. Here it is between those two angles. Then we have angle side. So we have an angle and a side. And it's not included on that one. So it kind of goes in order with our letters. So our letters, again, kind of help us quite a bit. Two methods that cannot be used are angle, because you could have any side length. Angles don't always determine that. And then side angle, which is our bad word spelled backwards. We don't spell that bad word, and we don't spell it backwards. Because again, those two sides, if it doesn't include the angle, then it doesn't really, we can't prove congruence. And if we draw all kinds of pictures of two sides that may be the same, but some random angle off to the side, it could still mean that we have a different measurement and they're not congruent. So let's go ahead and take a look at this first example here. So we're going to have 5 steps in this proof. If you want to go ahead and kind of set that up and put our first stuff, both of those givens, as our step 1, and then our last step 5 is going to be what we're trying to prove. So go ahead and get that set up, and then we'll take a look at this together. All right, so we've got our givens, and then we've got what we're trying to prove. So let's see, what do we have? Well, we know that WR is parallel, so I'm going to put a little arrow, parallel to ED, so I'm going to put those markings in. And then L is the midpoint of WE. So that's going to split this and this into 2 congruent pieces, which is where we're going to go now. So WL is congruent to LE because of the definition of midpoint. All right, then from there, if those are congruent, then we can look at, in our picture here, these are vertical angles. So we can go ahead and mark that and say that angle RLW is congruent to angle DLE by vertical angles theorem. And then where we can go from there is if we have parallel lines, we can go ahead and mark our alternate interior. So angle W is congruent to angle E. Alternate interior angles theorem. And then lastly, we now have, let's label it, we have an angle, we have a side, and we have an angle. So it's angle, side, angle in that order, because this is an included side between the two angles. All right, so we're going to do kind of that same thing. Let's write this one. I'm going to kind of do this one in a little bit more of a flowchart type way. So I'm going to go ahead and write out my congruent pieces. And then we'll see where we can go from there. Making sure that we mark our picture as we go, because that really helps. Okay, so where can we go from here? So let's mark our picture. KL is congruent to JM. And then we have some angles here. NKL is congruent to NJM. Okay, so now where can we go after that? Well, looking for anything that's sharing either an angle or sharing its side, it looks like N is congruent to N. We could go ahead and mark that by the reflexive property. Oh, let's put given underneath here. Given. And then this is reflexive. And it's kind of just on its own. We can pull that from the picture. I don't think there's anything else we can really pull from the picture, so let's go ahead and use our information that we have there. Let's mark N. There we go. Okay, so now we have, let's see what we've got in our picture. We have an angle and an angle and a side. So it says use angle, angle, side, which we have. So what does that prove? That proves the triangles are congruent. And what triangles? Triangle NJM and triangle NKL are congruent. And then from there, we can prove pieces. So we can prove any other part, any other side lengths that are corresponding to each other, we can prove by CP/CTC. There we go. All right, so I'm going to kind of continue with the flow chart here on this next one. Let's go ahead and put all of our given stuff in the first box. So let's go ahead and make a box here. And then we're going to kind of just fill in all of our pieces into that first box and then see where we can go from there. All right, so let's go ahead and mark our picture with the given information. It looks like we have X is congruent to V, those angles. We have angle YZW is congruent to YWZ. Okay, and then we have XY, that segment is congruent to VY. Okay, so it looks like we have an angle and a side. If we kind of look at our triangles, they're kind of overlapping. So this is one triangle, and then this is the other triangle. So you can kind of see them like that. So we have an angle and a side, and if we use angle, side, we can prove the triangles are congruent. So that's triangle XYZ is congruent to triangle VYZ. So if the triangles are congruent, then we can go ahead and prove the parts are congruent, because our goal is to actually get XYZ is congruent to VYW. Okay, so that's our end goal here. Triangle XYZ is congruent to triangle VYW. So let me kind of erase some of my parts so you can see that a little bit better. Okay, so triangle VYW is this one right here, and we want XYZ. So these outer triangles we're trying to prove. So we've already proved these triangles. Now we're trying to prove these kind of smaller end triangles. So now let's go ahead and go from angle, side. We can prove that YZ, because we need this side here, YZ is congruent to YW because of CP/CTC. Because those triangles are congruent, then that side corresponds to YW, that side. Okay, so now we can go ahead and prove we need the angle, because all we have is just angle, side, side, which we know spells our bad word, which isn't enough. So an angle, a side, and a side is not enough to jump here. So what do we need? Well, we need at least either this included angle up here or here. We need angle, angle, side, or we need an included angle. And we can actually go ahead and do by our congruent supplements theorem, because these would be supplementary to that. This would be supplementary to that. We could do congruent supplements theorem, which says if they're supplementary to the same angle, then they are congruent. So that is YZX, congruent to angle YWV. So now we have this angle. Now we can use angle, angle, side to show those end triangles are congruent. All right, down here, which method would you use? Well, let's mark anything that's not marked, like this right here, reflexive. So we have an angle and a side. So we could use angle, angle, side. Here we can mark again, reflexive. And then we have parallel, which means we can go ahead and mark alternate interior. So we actually have a side, an included angle, and another side. So side, angle, side. And then down here, this bisects angle KLM, so that is congruent to that. And by the reflexive property, that is congruent to itself. And then it's already marked K and M, so we have an angle, and a side. So angle, angle, side. All right, so flowchart proof here gives us a little plan to help us out. Let's start with what is given, and then we'll kind of work our way from there. You can kind of probably do this in two different ways. So let's show both because it says first possible and then second possible. So I'm going to go ahead and split this into two kind of spaces here. And then let's start with our first plan and do that approach. And then we'll take a look at the next plan. So go ahead and fill in a box here with all your given. Probably for both, you could go ahead and do your givens. And then we'll go from there. All right, so for our first plan, our first possible approach here, it tells us to use the parallel lines theorem and vertical angles. Okay, so the parallel lines, then we can go ahead, if we already know that RQ is congruent, it's marked, and so are the parallel lines, then we can go ahead and mark R and T congruent because of alternate interior, as well as that angle Q and angle S. So alternate interior angles. So now we've got our angle, side, and our angle. And we can show that our triangles RUQ is congruent to triangle TUS, what we're trying to prove. All right, so we're going to do kind of a similar thing, but now we're going to get angle, side, angle in our second approach. So let's go ahead and take a look at what's going to come after this. So this is given, and then we're going to use parallel lines theorem twice to use, that was our second approach. Right there. So now we need angle, angle, side, because we're going to use vertical angles. Jumping ahead of the game here. So this one is actually our second, and this one is our first. So we've got that kind of switch there. Okay, so alternate interior again, we're still going to use that, and that's going to do angle R is congruent to angle T. And then we're going to use vertical. Okay, so vertical angles. And let's go ahead and put that here. All right, so here's my vertical angles right here. RUQ and SUT. And then we also had our alternate interior. There they are marked. So now we have an angle and a side to prove those triangles are congruent.